Hi everyone, my name is Usurupati Avinash. Today I am going to explain about the project product recommendation system. In this project, we have to give a sample product ID, then we will get predicted product IDs, similar product IDs from the clustering model, the best clustering model. In this product recommendation system project, we have taken the rating data frame. In this data frame, we have four columns: user ID, product ID, rating, date. In this rating data frame, the shape of the rating data frame is 78,245 rows and 4 columns, having a non-null value of 78,245. Each rating data frame user ID have a count values. Each rating have a count value of 43,360 count for rating of 5 and 4,592 of count for rating 2. Also count values for date. We don't want column date, so that's why we have removed the date column from rating data frame. And also to handle the missing values, we have found is there any null values we have found. So there are no null values in user ID, product ID and rating. For identifying and correcting any inconsistencies in this data set, we have found .d types. So from this we found that there are no inconsistencies in data types. For detecting and treating any outliers, I have taken box plot. So this is the box plot. From this box plot, I can't find any outliers. So these statistical summaries I have found from this data set where total count of the ratings are 78,245, mean is 4, standard deviation is 1.38, minimum is 1, 25% value is 3, 50% value is 5, 75th% is 5, maximum value is 5. Histograms have at 5 there is lot of rating values. Also at density plot there is high number of density at rating 5. At bar plots there are high density at 5, after that 4, after that 1, after that 3 and after that 2. These are the top 10 most frequent user IDs that I have found, and these are the top 10 most frequent product IDs that I have found. And pie charts having highest number of 55.4% of uh, rating as occupied by rating 5. From the pie chart, user IDs highest was occupied by these two product IDs with 12.5 percentage. Top 10 most frequent product IDs are this product ID with 15 percentage, and these are some of the scatter plots I have plotted between average rating versus number of ratings per product. The scatter plot was showing like this. So there are density at 0 to 25, highest density is there. Also at average rating versus number of ratings per user, there is highest density at 4 and 3 and 2 and 1. These are the heat maps. Number of ratings versus number of ratings is 1, as you know. Number of ratings versus average rating is 0.3. Correlation heat map for user statistics is number of ratings to average rating is 0.02. For the pair plots, there are lot of density at zeroth value, average rating versus number of ratings. It is reducing at 200 values, and here the density is very high at 0, but number of ratings versus average rating, it is increasing from zeroth value to highest rating like 0 to 5. 5 the density is increasing. These are the pair plot of user statistics. So for pair plot number of ratings versus number of ratings, it's at zeroth value it's higher, and also at average rating it's at 5 is higher. These are violin plots. After that I have did feature engineering. There I have measured some user statistics into the new data frame. Then I have created rating deviation from product average column, created rating deviation from user average column, and also I have defined rating features data frame. These are the distribution of log transform product number of ratings. From 0 to 5, it's reducing constantly. And from user number ratings log, distribution of log transform user number ratings. At 0 to 0.8, it is very highest at peak. At 1.0 to 1.2, there is a little bit up. And also at 1.4, the minimum value of up is we can observe. After that, I have did feature selections and I have selected some features for outlier detection. I have initialized the isolation forest. The contamination of 0.01 means as expected for the data to be outliers. So I have fitted the model and predicted outliers. I have taken 1 for inliers and -1 for outliers. So I have added outlier prediction to the data frame. Here I can find outliers. For outliers, I have taken as -1. So these are the outliers values. And for non-outliers, I have taken equal to 1. These are the non-outliers. Total number of outliers detected is 7083. And original data frame shape is 78,245, 12 cleaner data frame shape after outlier removal is 77,462 rows and 12 columns. Percentage of outliers removed is 1%. I have dropped the temporary outlier column from the cleaner data frame. So after that, I have did sparse matrix representation, user product matrix. Since we have large number of user products and uh, users and product, most users have rated only a small fraction of products. Creating a full pivot table would require large RAM, that is like 3 billion cells we need. So this will happen in crashes. Instead, I directly build a CSR sparse matrix which only stores non-zero values. After that, I have mapped user ID and product ID to integer indices. User ID categorical shape is 77,462 rows and product ID categorical shape is 77,462. These are the user ID values, and user ID shape is 77,462. After that, I have built sparse matrix. So in this sparse matrix, compressed sparse row sparse matrix of data type float 64 with 77,462 stored elements and shape is 76,168 rows, 39,967 columns. Sparse matrix shape was 76,168, 39,967. Total non-zero ratings are 77,462. There is 99.9975% of sparsity. After that, I have done predictive power score to find and discuss the relationship between the features. So I have selected some numerical features for predictive power score. So I found PPS matrix from above values. So these are the PPS scores I have found it. And relevant shape of the PPS is 81 rows and 4 columns. I have calculated pivot scores and also added PPS matrix heat map. So here highest is 1.0 with having correlation and lowest is 0.0 and having highest, 1 is having highest and also 0.98, that is between rating and user average rating we have got 0.98. Also, I have found correlation matrix of numerical features. Here 1 being the highest and 0.0 is the lowest. So product number ratings log and product number ratings have highest at 0.78 of correlation. After that, I have found uh, item collaborative filtering in model building and evaluation. So here I have compressed sparse column, sparse matrix of data type, 77,462 stored elements, and shape is 39,967 rows, 76,168 column. Have found it cosine similarity between items. So item similarity matrix shape is 39,967 rows, 39,967 columns. I did clustering analysis by k-means clustering. Have selected feature selection for clustering using the engineered numerical features from the cleaner data frame. So I have preprocessed the scaling because k-means is sensitive to the scale of the features. After that, I have found uh, optimal k-value using elbow method. So where here we can find optimal value of k is equal to 4 by elbow method because there is a bend at this point at 4. So I have applied k-means with optimal k equal to 4 value from elbow method. So I found cluster values 0, 1, 2, 3, and each cluster value having each column with mean values I have found. After that I have found each column having each data. After that I have found some scatter plots. So for evaluation and performance I have taken silhouette score. K-means clustering have silhouette score of 0.485. After that I did hierarchical clustering. I plotted a dendrogram. So the dendrogram is looking like this. So from the dendrogram I can observe that total number of clusters is like 4 clusters. I have applied agglomerative clustering. Here I have found sample size of 7,746 and I have found indices. So I have featured some samples. So the length of scale feature sample is 7,746. After that I have applied agglomerative clustering to the sample data. I have found cluster labels sample. So I have created some temporary data frame for the sample features with their cluster assignments. So here is the cluster values. This sample data frame has value shape 7746, 12. So I have found mean value of each hierarchical cluster feature columns. So with each hierarchical cluster, I have found mean value of each feature. So bar chart of hierarchical clustering is like this. So I have did some scatter plots for hierarchical clustering. So for evaluation, I have found silhouette score. Silhouette score for hierarchical clustering 0.450. After that, I have performed DBSCAN with epsilon parameter of 0.5 and minimum samples of 5. I did scaled features. Then I did DBSCAN label samples. I took 10 clusters equal to 10. I got 10 clusters and noise value of 31 values. So estimated number of clusters are 10 and noise points are 31. I have taken a cluster column. So here I have found mean values. Each cluster mean values of each uh, column. So bar plot of DBSCAN is like this. Product average rating, user average rating, product number ratings log, user number ratings log. Scatter plot is like this between product average rating versus user average rating. log product number rating versus log number user ratings. So after that, I performed an evaluation of performance metrics. Silhouette score I got 0.203, which is very lower. So I did tune. After tuning epsilon parameter tune value of 1 and a minimum samples parameter tune values 5, I got a good number of clusters like 3, and also noise points also 6, which are reduced. So here the shape is 7746 rows, 15 columns. I got 3 clusters, and the bar plot is like this. A scatter plot is like this. So here in this tune DBSCAN clusters, I got very less number of noise points compared to the normal clustering method. So I have found silhouette score for tuned DBSCAN where it got 0.610, which is very better than previous DBSCAN clustering model before tuning. So I am taking DBSCAN tuned model as clustering for this product recommendation systems. After that, I did recommendation system based on item based collaborative filtering. I have taken product ID to index values and index to product ID values. Then I defined a get item recommendation. So I have given a sample product IDs. Then threshold values I have given 0.0 to 0.9. I got some recommendations around 100. I for first 10 I have shown like this, and after the I have shown and 90 more like that. There are number of ratings for this product ID is 21. So product ID, this sample product has 21 ratings. So we are continuing with this product. After that, I have built function to predict user ratings for a product. Then for predicting a rating, I have defined function. If I take example user ID as this user ID and target product ID for prediction is this, predicted rating for user, this user on product, this product is 5. So I did some evaluation by training and testing splitting. So training size is 61,969 rows, 3 columns. Testing size is 15,493 rows, 3 columns. So I have rebuilt its sparse matrix on training data only. So training data category shape is 61,969 rows. So user ID, training user ID shape is 61,969 rows. So here I have compressed sparse rows, sparse matrix of data type. 61,969 stored elements and shape is 61,129 rows and 34,044 columns. So here I have transposed that into train item user matrix. I found train item similarity values. Here I have found train product ID to index values, also train user ID to index values. So train sparse matrix shape is 61,129 rows, 34,044 columns. So after for predicting on testing a set and evaluating, I got valid test samples of 226. Predictions made 226 out of 500. Mean absolute error value is 0.4690. Root mean square error value is 0.8348. The most frequent rating in the entire dataset is 5. This suggests that a threshold of 5 or higher for relevant liked items could rank the most common positive feedback. After that, I found precision of 80%, recall of 75%, F1 score of 77%. So here we found total prediction 226, predicted as likelihood greater than or equal to 4 as 150, actually likelihood is 161, average predict rating is 4.54, average actual rating is 4.60. After that I have deployed. So in this deployment, I have saved everything to the Streamlit app. So that I have done, I have created some .pickle file, and also I have created .npz files. Each file having size of pickle file have 5.75 MB and pz size have 0.26 MB. So I have saved everything to the Streamlit app that we needed. I defined some artifacts. Then I have opened this recommendation underscore artifacts at pickle file. So I will show you now the Streamlit app from here. So this is the URL Streamlit app. So from this URL, I got this Streamlit app of product recommendation system using item collaborative filtering by taking DBSCAN clustering. So I will try out some sample product IDs so that we will get some recommended product IDs. Suppose taking this sample product ID, I have pasted here. Like if I click on get recommendations, I got the cluster as zeroth cluster and also average product rating, average user rating, log product rating, log user rating, and also recommended product IDs and also similarity scores. If I take threshold value of greater than 0.7, I am taking this product ID. So if I click get recommendations, I am getting this DB scan of cluster is 0 for this product value. Also average product rating is this value. If I want more number of recommendation, I can increase this threshold value until 20. So after if I click get recommendations, I'm getting more than 10, 20. I am getting 20 recommendations. And also for this product ID, if I click on this and also if I set limit as 5 and if I get recommendations, I'm getting these product IDs of similarity scores. If I improved my similarity threshold till 0.7, if I click get recommendation, for this product has recommendations but was not included in the DBSCAN clustering sample. So it is showing similarity results only. So this has highest similarity score of 1. So this is the product recommendation system that I have built using item collaborative filtering, DBSCAN clustering. So thank you.